Recording in progress.
In the section 2.3, now it is mentioned that how electrons are arranged. We will see that there are different shells. Within those shells, the electrons are arranged. In the previous lecture, we discussed that there are firstly we discussed that uh, in the element, how elements are formed from the similar type of atoms, right? Similar type of atoms. And within atoms, there are subatomic
Yes.
particles.
Particles, electrons, neutrons, protons.
Yes, electrons, protons, and neutrons. Okay. Now, and also we discussed that the
Protons,
protons and
neutrons.
neutrons are present in the nucleus. Okay. Protons and neutrons are present in the nucleus,
Yes.
and the electrons
Present in nucleus.
present in the shells. Okay. The electrons always reside in the shells. Okay. Just like
Shell.
this.
Yes.
But in the center nucleus, you have what? Proton and neutron. Proton and neutron are always present in the nucleus. Okay.
Yes.
And that's why we say that
Yes.
overall charge of the nucleus is, what's the overall charge on the nucleus? You see, in the nucleus you have
Overall
protons and
charge.
neutrons. Yes. So what will be the overall
Mhm.
charge on the nucleus?
Nucleus, it will be positive.
Yeah,
No,
overall charge will be
neutral.
You are right. You are right. It will be
No,
positive. Because you see, I
no,
am
I meant
saying in the nucleus,
neutron would be
yeah, in the nucleus you have protons as well as neutrons. Protons, neutrons,
yeah,
protons, neutrons. These circle represent the neutron. Okay, proton, neutron. So you see
yeah,
overall charge. What is the overall charge on the nucleus?
positive.
Positive charge. Okay, and then electrons reside in the shells. Okay, the electrons reside in the shells.
Yeah.
Now we will see how the electrons are present in these shells. How the electrons are arranged in the shells. Okay, this is our
Mhm.
topic. Uh, electrons are arranged. मुझे याद नहीं, मैंने रोटी नहीं खाई. Electrons are arranged in the shells around the nucleus. The first shell closest to the nucleus is the lowest. Okay, one more thing. Why these shells are there? Remember this thing. These shells have different
Yeah.
energy levels. Okay, these shells have different energies. Okay, different energies. Each shell has its own energy.
Mhm.
Okay, and the shell which is closest to the nucleus, the first shell, it has the lowest energy. Okay, it has the lowest energy. Clear? And when you
Yeah.
go further, the energy will increase. Okay, so it means in this case, if you see this one, which shell will have the highest energy, the first shell or the third shell?
What?
Which shell in this diagram, which shell will have the highest energy?
The first one?
No, I am saying that first shell has the lowest energy. Okay, the first shell, this
Uh,
first shell has the
Third one. Third.
lowest energy. Yeah, third one. After this, the energy will increase. It will go on increase. The number of shells will increase and the energy will increase. So the last shell will always have the highest energy. Okay, it will always have the highest energy. Okay,
I see.
read from here what they have mentioned.
Yes.
The first shell closest to the nucleus is the lowest energy level.
Oh,
Clear?
I think
The
there's someone
closest,
from.
yeah.
Just,
Sorry.
just give me one.
Okay, okay.
Someone is here. Just give me one.
Recording in progress.
Yes, I was telling you about this that the lowest energy is of the shell which is closest to the nucleus. Okay, the first shell. The first shell's energy is
Yes.
the lowest, and then the further a shell is from the nucleus, the more far apart it is from the nucleus, the higher the energy will be. Okay, the higher the energy level will be.
Yeah.
Okay, one more thing.
Yes.
What this energy is telling us, what this energy level is telling us, that this energy is specific. Okay, this energy is specific. It means one more thing we are going to discuss over here is that each shell can hold only a certain number of electrons. Okay, there is it is not the case
Yeah.
that you can fill all the electrons in one shell. It is not like that. There is a limit of each shell. In beyond that limit,
Mhm.
that shell cannot fill the electrons. Okay, for example, the first shell,
Yeah.
this is the first shell. The first shell it has the capacity of holding only 2 electrons. Okay, so it will only hold 2 electrons.
Yeah.
This one and this one. Okay, so it will only hold 2 electrons.
2
Clear?
electrons.
Yeah. Similarly, the second shell's capacity is to hold 8
8.
electrons.
No.
Yeah.
Yeah, 8.
Okay. 1, 2,
And the
3.
third also holds 8.
Yeah, it also hold 8 electrons.
Yeah, but after like the fourth or fifth or any after
Hmm.
third will hold more 10.
Yeah. Yes. Exactly.
Yeah.
So this is the case here. This is what we say the electronic configuration. Or electronic configuration means how the electrons are arranged. Arrangement of electrons is known as
Yes.
electronic configuration. This is what I was asking you in the
Correct.
previous classes that you know about electronic configuration.
Mhm.
This is what we say electronic configuration is. So whenever you write this, how you will write? Basically, you will write it by this. That in the first shell you have 2 electrons, right? You will write 2. Then in the second shell, how many electrons are there?
What's it called? 8.
8. So you will write 8, then comma. How many electrons are there in the third shell? 1,
10.
2, 3, 4, 5, 6, 7, 8. Now this in this
No,
picture,
8, 8, 8,
8.
8, 8,
So you
8,
will write
8,
it
8,
like this.
8.
Okay. This is how we write the electronic configuration of each atom, each atom of the element. Clear? These are
Yeah.
the rules. These are some specific rules. Okay, one more thing. As I told you that the energy is fixed. Energy of each level is fixed. What does it mean? It means, for example, I am just giving you the example. For example, this is the first shell. The energy of this shell is 546 Kelvin, kilojoules. Okay, kilojoules of the energy. Kelvin is the unit of temperature. Its
Mm.
energy is
Yeah.
546 kilojoule. It means if you give if you want to if you have the energy of 547 kilojoule, that electron cannot enter in the first shell. Okay, why? Because this
Mhm.
energy is
Yeah.
fixed for the first shell, just like the boiling point and melting point that are fixed. Similarly, the
Yes.
energy of these levels are fixed. The terminology for this is known as quantized. Okay, this is known as quantized. The
Yeah.
shells have quantized energy.
Quantum.
Quantized means fixed energy. Are you getting this?
Fixed.
Each shell has a fixed
Yes.
value. You cannot exceed that value or you cannot decrease that value. If you want any electron to be in that particular shell, you need exact amount of energy. Okay?
Mm-hmm.
Just like
Yeah.
if I want the electron in the first shell, so I need to give 546 kilojoules of energy. If I will give 544 or
Yeah.
545 kilojoule of energy, that energy is not sufficient for the electron to reside in the first shell. You need to give exact
Yeah.
this 546 figure. Okay? And this
Yes.
terminology is known as quantized. This we will discuss in the upcoming
Yes.
chapter, but for the general knowledge, you can write it on your book as well. This is known as quantized shells, quantized energy shells. That every shell have a fixed value. Okay, are you clear with this? What is the electronic configuration and why we have different shells? Why we cannot? If I ask you, why can't we put all the electrons in the same shell? What can be your answer?
Because each shell has like a fixed, has a quantized
Energy
energy, like has
as well as
energy
it has the capacity,
uh,
it has a certain capacity
of
of holding,
electrons.
yeah, of
Like,
holding the electrons.
like,
It cannot hold
like
more
two
electrons
electrons.
than of that capacity. Okay, each shell can
Yeah.
hold only a certain number of electrons. For example, the first shell, what is the maximum capacity of the first shell?
Maximum capacity 2.
Yeah, it can only hold 2 electrons. What about the second one?
8.
8. Third,
8.
yeah, it can hold 8, but when it is outer shell, otherwise it can have 10 or more electrons. We will see that example in the
Mhm.
upcoming
Yeah.
class. Okay, so this is known as electronic configuration. Now they have mentioned the electronic configuration of 20 elements. Firstly, you see, this is the this is group number 1. Okay, what was the common thing we discussed about the groups? That in the groups, the valence shell electrons are same, right?
Yes.
Valence shell electrons are
Are
same in number.
the same
For example, if we see the group 1, all the atoms of this, all the elements of this will have one electron because this is group one electron in their valence shell. Okay, one electron in their valence shell. We can
Yes.
check it. You see the hydrogen in this, there is this just one electron, right? So this is the one shell,
Yeah.
only shell, and in this only shell you have one electron. Now we see the lithium. What is the outermost shell? The second shell is the
Uh,
outermost shell. Okay, the
one.
second shell is the outermost
Yeah,
shell, and in this
it
there is
has
one electron.
one electron.
Yeah. So
Yeah.
in the sodium, this is the last shell, the third shell, and you see
Yeah.
there is just one electron.
Yeah.
Similarly, if we see this potassium, the last shell, this is the last shell, and in the last shell you have just one electron,
One.
right? So this one, what is this telling us? That they are, why they are in the group one? Because they all, the valence shell electron in all of them is just one. Okay, in the
One.
valence
Yeah.
shell there is just one electron. That's why they have a same group, right?
Mm-hmm.
And
Yeah.
what about periods? Okay, when you see periods, you will see number of shells. Okay, in the periods, number
Yes.
of shells are same. Number of shells, not number of electrons. Number of shells are same. Like for example, if
Yeah.
I say the period one, it means in the period one there will be just one shell. Okay, you see hydrogen and helium. How we check period?
Yeah.
From left to right, right? We check period from left to right.
Yes.
And how we
Left to
check
right.
group?
Yeah.
We check group from top to,
The bottom.
yeah, top to bottom. So we check the group from the top to bottom. All the elements of the group one have valence shell in there, has one electron in their valence shell, right? In the group one. Now we are checking periods.
Yes.
How you will check period? In the period number one, the atoms, the elements of the atom have just one shell. Okay, the shell will be one.
Yes.
No matter how many electrons are there. You see, there is a difference. In this, there is one electron. In this, there are two electrons, right? In the same shell.
Yes.
You just need to check the shell. When we are checking the periods, you just need to check the shell. If I say period number one,
Shell.
it means the all the elements of the period one will have just one shell, right?
Mm-hmm.
If I talk about the period number two, what will I say? What is the
It
common
has two
thing?
shells.
Yeah, you see,
Two shells.
all of them have two shells. The two shells, two shells, two shells. Okay, all the elements are having two
Yeah.
shells. Okay, now
Two
when we go
shells.
further, this period number three, they will have how many shells?
Three shells.
Three shells.
Three shells.
Period number four,
Four
four
shells.
shells. Okay, this is how we arrange the periodic table. Okay, if I ask you in the paper in the test, how we arrange the elements in the periodic table, you will say on the basis of the periods and groups we arrange them. Okay, and in the groups,
Yeah.
if we talk about the each group, the elements of the each group will have same number of valence shell electron. Okay, same number of valence shell
Valence shell electron.
electrons. This is the similarity in them. Okay. In the periods, if we talk about the periods,
Yes.
they will have same shell. Okay. Same
Yeah.
number of shell. If I talk about the period one, it means there is one shell. If I talk about period four, it means
One
there
shell.
are four shells.
Four
Right.
shell.
Okay. Are you clear with this?
Yes.
Okay. Now I am erasing this and I need to tell you about the electrons, how the electrons are arranged. There is no need to remove this. Okay. First thing, hydrogen, you know, this is very simple. Hydrogen is one. It has just one electron and one proton. So its atomic number, it will be written as like this. What about the neutron? How many neutrons are there in this hydrogen?
In nitrogen?
No, hydrogen. How many neutrons are there
Oh,
in hydrogen?
hydrogen. One.
No. If there is one neutron, you know what will be the atomic mass? Its atomic mass will be this. But this is not the atomic
Two.
mass.
So it will be
Why
zero.
I'm saying that yeah, it will be two because you know how you can check. I simply told you this is the atomic mass. Okay, atomic mass
Yeah.
minus the proton number. So you will get the
Oh,
neutron.
yeah, proton number one.
So there is zero proton, zero neutron in this. Okay,
Yeah.
how you get
Mm-hmm.
atomic mass minus proton number? You will get the
Proton number.
neutron
Yeah.
number. Okay, this is the simple equation. You can write it on your
Yes.
book. This is the simple method to check the neutron number. And how we check the electron number?
Yeah. Electron number
Hmm. How we check that? How many electrons
plus
are?
proton.
Yeah, simply you will check the atomic number, atomic mass, or the atomic number, the
Yeah.
proton number. What is the proton number? That proton number is equal to the number of electrons, right?
Yeah.
In a neutral atom,
Yes.
we have discussed that the number of protons are equal to the number of electrons. Okay, number of protons
Yeah,
are equal to the number of electrons, right?
electrons. Yes.
Okay. Yes. Now we are discussing. This was about the first hydrogen. Now let me change the color. And if you see this helium, this is helium. Okay. Can you tell me what is
Yeah.
the how many protons are there in this?
In
Protons.
protons, 2.
2 protons are there. Okay. And
Yes.
how many neutrons are there?
Neutrons, 2.
This you can check this in this table. They just have mentioned about the protons. You can check from this. Yeah, this one, helium. Okay. This is helium, 2 protons, right? And 2
Yeah, 2
neutrons.
neutrons.
So what
Yes,
will be the mass number?
the mass number will be. Wait, so
How
if you
we
have to
get the mass
do
number? Mass number is what is mass number? Mass
it's
number
2
is
what's it called, proton minus
proton
neutron.
plus neutron, right? Proton plus
Yeah,
neutron.
plus neutron. Yeah, plus
So
neutron.
you have
Yeah.
2 protons plus
So 4.
2
No,
neutrons,
2,
right?
2.
Yeah, you're right. This is
2.
4.
Yes.
Atomic mass will be 4.
4.
Why are you confused?
I think
Okay.
sometimes I'm wrong.
Okay, we can do this on other slide in the one note. These are just mass number, atomic number. Okay, whenever we have mass number, it means it is the total of protons plus neutrons. Okay,
Neutrons.
right.
Yes.
If I talk about the atomic number means just number of protons. Okay, atomic number is just the number of protons, right? Are you clear with this? Is there an issue?
Oh, that's no. Now I get it.
Okay. For example, if I say lithium, okay, I know that I am telling you the information that its proton number is 3 and the neutron number is 4.
Yeah.
Okay. Now I am asking you what is its atomic number? What is its A? The mass A is always mass number. Okay, A is mass number. Okay, mass number.
4.
And this is proton number. Z is proton number. If I talk about the mass number means what is the mass number? Protons plus
The Z
neutrons.
and neutrons.
So what will be this? Proton are 3 plus neutrons are how many neutrons are there?
Are you? I'm seeing the PDF still.
Oh, sorry.
I'm
I
still on
was
the PDF.
I was using the one not over here. This is what I was telling you that for example, you know the mass number is what is mass number? Mass number is protons plus neutrons, okay?
Yeah.
And it
Yeah.
is represented by
Yeah.
A. Atomic number is represented by Z, and it is just the number of protons,
Yes.
right? This is the information I have
So the
given you about the lithium that it has 3 protons and
yeah.
it has 4 neutrons. Now can you tell me what will be the atomic mass? 3 plus
the atomic
protons
mass
plus neutrons. Yes,
neutrons, so 7.
it will
Yeah,
be
7.
what will be the atomic mass?
7.
7, right?
7.
And if I ask you what will be the proton number of this?
3.
Yeah, 3. So how
3.
you will write it? You will write it like this: lithium, 3 and 4. Clear? You will not write. You can't write 7 here. Okay. Sorry. There will be over here. We will write 7. This is wrong because why we have write 7? Because that is the total of the proton and neutron number. Clear? Let me write it over
Yeah.
here. 3 and 7. Clear? Are you clear with this example?
Yeah, I got it.
Okay. If I give you the information about the sodium, there are 11 protons and there are 11. Neutrons are 12. Okay.
Yeah.
Now can you tell me its atomic mass and its proton number?
Okay. So the
What
atomic
is atomic mass?
mass would be
Mhm.
what's it called 23.
Yes, it means you are
23.
adding
Yeah.
proton
11
and you're
plus 12
adding neutrons, right? So this
neutrons.
will be
Yeah.
its,
Yeah.
yes. What about proton number?
And the proton number will be 11.
And what about the electrons? How many electrons will be there in this?
23. So 23 minus 11. Yeah. You get
No.
it will be 12. You know.
Electrons. Think about electrons. Electrons. Doesn't electron equal to the proton number?
Oh yeah. Yes. Electrons and protons are the same. Yeah.
11. So electrons will be
So it
11.
will be
You
11.
are confused with this.
11.
If they you see this is the equation, okay? If they give you, if they
Mhm.
want to ask you the neutron number, for example, what I'm saying is that if they ask you neutrons, okay, just they ask you the neutron, what you can do? You can you have mass number, right? The mass number is A. Then what you can do? You can subtract the proton from it, okay? Isn't it? This
Yeah.
equation,
Yes.
this is the equation. You can change it. How you can change it? For example, this was the mass number. Okay, let me write it over there so that there is no confusion. Mass number is represented by A. If I want neutrons, how can I change this equation? Simply, these protons are added over here. These protons will be on this side and they will be subtracted. Okay, A minus,
Yeah.
simply you can write mass number minus proton number
Proton.
and you will get neutrons. Clear?
Yep.
This is the equation. For example, they have mentioned
Yeah.
that they have mentioned this. Okay, this. Now they are asking you what is the proton
Yeah.
number, what is the neutron number, what is the electron number. Can you tell me now? How can you tell me? Firstly, what will be the proton
Yes.
number? How many protons are there?
What's it called? The proton number would be 20.
Yeah, 20. Okay. Neutrons?
Yeah. And neutrons would be what's it called 40 minus 20.
Yes. How you get this 40 minus 20?
Because
This is the equation. The
we
mass
plus,
number,
yeah,
total mass number minus number of
minus
protons.
proton number.
So you will get the
Yes.
neutron number. That is 20. Okay, good.
Yeah.
What
So
what about
yeah, it will
electrons?
be 20 electrons are same as protons, so 20.
Yes. So it is 20. Okay. Are you clear with this? Whenever they
Yes.
ask you the
Yes.
neutron number, you will just subtract the mass number, the protons from the mass number. Simple. Simple is that.
Yeah.
Okay. Let's take
Yeah.
another example. For example, we have okay. We have this one. Can you tell me it's okay. Now I'm writing this. Mass number firstly you need to tell me. Then proton number. Then you need to tell me this is proton number. Then this, and this. Yeah. Okay. What is A for this chlorine?
Atomic mass number.
Now what is
So
that?
the
Say this.
atomic was- uh,
What's that?
okay. So for the atomic mass number, it will be 35.
Yeah, 35.
35.
Yeah, atomic mass number is 35.
Yeah.
Great. What about
And
proton
the
number?
Z is the proton number or atomic
Hmm.
number.
That
So
is
it will be 17.
yes.
17.
What is proton number?
And proton number is 17. 17.
Yeah, so the same. What about neutrons?
Neutron would be 35 minus 17,
Hmm.
18. So
Yeah, 18.
neutron would be 18.
What
Yeah.
about electrons?
And the proton and electron are same, so 17.
Okay. Are you clear with this? How we calculate the neutrons? You just need to
Yes.
subtract the proton number from the mass number. Simple, right?
Mhm.
Now they
Yeah.
have mentioned this over here. Okay. Okay. Now
Yes.
what I was telling you about these. You see, this is after hydrogen. In the period one, you have helium. Okay, and in helium you have two protons and two. There are two protons and two neutrons. So what will be the mass number? What will be the mass number? There are two protons and two neutrons. How you get the mass
Two
number?
neutrons and two.
Hmm?
Wait. To get the mass number, we have to. What's it called? To
Mm-hmm.
get the mass number, like we have to do proton plus
Hmm. Yeah, you're right.
plus
Proton
neutron.
plus, yeah, proton
Proton
plus
plus
neutron.
neutron.
So what? How
Each
many
one.
helium will be there? The what will be the atomic mass of the helium?
It's four.
Yeah, it will be 4, right? Are you clear with this? Simply, they
Yeah.
can ask you like this.
Yes.
They can give you the number of neutrons, like they have mentioned number of neutrons are 3, proton numbers are 5, and then they give you a substance and they can ask you to complete this. So you will write 5 over here and 8 over here. Now atomic mass will be 8 because you will add neutrons and protons, right? Are you clear with this?
Yes.
So you must know by all the ways how we can calculate this number. Okay, now
Mhm.
second period in the second period we have two shells. Okay, the third is lithium. You see this lithium. Now, how they mention the lithium, the electrons in the lithium. Firstly, in the first shell, what is the capacity of the lithium? First shell
Capacity
capacity
of
is of
helium. Two.
2. In the first shell, you
Yeah.
can only have 2 electrons. So they have write it like this 2. Okay, then comma. The second shell will have just
One.
one
The
electron,
outer
okay,
shell.
because all overall there are just
Yeah.
3 electrons in the lithium, because the proton number of lithium is
Yeah.
3, okay, the proton number is 3. They
Mhm.
have in
Yeah.
this whole table they have just mentioned the proton number. They didn't mention the atomic mass, so you don't need to focus because they just mentioned the proton number because we are just checking the electrons, okay, we are just checking the electrons, we are not checking the
Mhm.
number of neutrons or all those things. So for that reason, they just mention the
Mhm.
protons and the electrons. Simple. These are
Mhm.
the electrons. Okay, in beryllium there are 4 electrons. There are 4 electrons. How these electrons are arranged? Firstly, in the first shell, how many electrons will be there? In the first shell.
First shell.
Hmm. How many electrons
It's
can be there?
two. Two
2. Okay,
electrons.
yeah, 2.
Two. Two.
So there are total 4 electrons in the beryllium. Definitely, the rest of the 2 will be in the second shell. Okay, the rest of the 2 electrons will be in the
Yeah.
second shell. So how we will write it? 2 comma 2. Clear?
Yeah.
Okay.
Yes.
So, okay. Now this is the group number 2. Okay, this is group number 2. What we check in groups? What we check in the groups from top to bottom? We check.
The period.
No,
No.
in the groups. What is the
From
specific?
top to bottom.
What
Like
is the similarity? Which thing is similar in particular group? If I talk about the group number 2, what is the thing which is similar in all the elements of the group number 2?
group number two.
Check this. What I have written here. Same number of.
Of valence shell. Yeah. It will have
uh,
two in the last.
Yeah, in the group 2, all the all the elements, the beryllium, magnesium, calcium, they all will have 2 electrons in their valence shell, right? No matter
Yeah.
how many shells they have, we have no concern with the shells in the when we are discussing the groups from the top to bottom. You don't need to check the number of shells. You just need to check the electrons in the shells. Okay. In the group number
Mhm. Yeah.
2, all the atoms, all the elements will have 2 electrons in their valence shell. Okay, you see the beryllium, it has 2 electrons in the valence shell, right?
Yep. Yeah.
Okay, then okay, now check this one, the sodium. Sodium is having 11 electrons. How you will arrange it? In the first shell, there will be 2 electrons, right? Are you getting this?
Yeah.
And in the second shell, how many electrons will be there?
Eight.
8. So total now total are 10. Okay, how many left?
Yeah. Uh,
2 and 8,
wait,
2
we
plus
have
8 is
one
10.
left.
Just one left. So you will
Yeah,
add one in
we
the
need.
last shell. Okay. One is in the last shell. So you
Yeah,
see this one, this
yeah,
first group. Every every element of this group has one electron in its valence shell. You see this? One electron in its
yeah,
valence shell. Clear?
yeah.
One electron in the valence shell. So you will write it by this 2. Then in the second shell there are 8 electrons. Then in this third shell there is 1 electron.
One
I
more.
hope you are clear with this.
Yes, yes.
Right? Okay. Now we can check the magnesium. Magnesium has total 12 electrons. Okay. It will be similar to the
Mhm.
sodium, but what will happen in the last shell? There will be 2 electrons. Okay. Because there are, firstly, in the first shell there are 2 electrons, right? 2 electrons in the first shell. How many electrons will be there in the second shell? 8, right?
Uh,
The
yeah,
maximum capacity of the
yes,
second shell is 8. How many left? 2 plus 8 is 10. And we said that magnesium has 12, total 12. So how many left? In the first shell we filled 2
12.
electrons. In the second
Yeah,
shell we filled 8 electrons. So 2 plus 8 is 10.
yeah,
How
and
many
this,
electrons are left?
yeah, and the last shell will be 2.
Yeah, last shell will have 2 electrons. So this is how you will write 2, 8, 2. You see this group number 2. In the group number 2, what we are checking? That there are 2 electrons in the valence shell, right? There are 2 electrons in
Yeah,
the valence shell, right?
yeah,
In the beryllium and magnesium. Okay. And if you see the period number 2, if you check the period, let me change the color. This is the period number 2 from left to right. You see how
yeah.
many shells are there? 2 shells. 1, 2. Similarly, 1, 2, 1, 2. There are 2 shells. Okay. So whenever you are checking the
Mhm.
period, you will always check from the left side to the right side. Okay. Left to right. And what you will check? That there will be same shells. Are you getting this?
Mhm. Yes.
Okay. I know this is a new concept. It will be difficult to absorb at the first, but when we repeat it by repetition, you will get to, you will be used to it, inshallah. And
Yes.
about the groups, when we talk about the groups, what we say is that in the groups, we check groups from the top to bottom. Okay, we check groups from the top to bottom. And what we check
But
in the group? What we check in the groups? Like if I want to check the group number
uh,
one, hmm,
yeah, like from top to bottom, you'll check the valence shell.
there
Like
will
it will
be
have the same valence
every,
shell, and
yeah, every element will
yeah,
have same number of, hmm, same number of
the same
valence shell
number of
electrons.
valence shell, yeah, electrons.
Okay,
And from left to right, it will have the same shell.
yeah, same shell in one period, in each period. Okay, if I talk
Yes.
about period number 2, it means there are 2 shells. If I talk about period number 4, it means there are
Yeah.
period number 4. If I talk about period number 4, how many shells will be there? Period 4.
Uh, yep.
Hmm?
Period 4, it will be 4 shells.
Okay,
4 shells.
period 4, 4 shells. Okay, I am writing this group number 1 and period number 4. Period number 5. What information we will get from this? Group 1. It means, group 1 means, what information this, all the elements of group 1 will have common? That they have
The
one
same valence,
electron in
one
their
electron. Yeah, and
valence shell. Okay. If I
yes.
talk about the period 5, what information I get from period 5?
Uh, uh,
There are 5 shells.
like
Okay.
5 shells.
5 shells. Simple. Okay. This is what I am telling you.
Yeah.
That groups tells us the information about
Yes.
electrons in the valence shell, while period tells us about the shells. Okay. It tells us about the how many
Mhm.
shells are there. If there is period number 4, it means there are 4 shells.